Hey everyone, welcome to another video of Basic Electrical Engineering. In this video we are going to solve the problem using the Thevenin's theorem. This problem is a bit complicated from the previous one, so let's see how to solve such questions. These questions may sometimes confuse the students, so we are going to solve it. Hope it will be helpful for you. The question has asked to identify current through 20 ohm resistor and of the network shown in the figure below, and it is asked to use Thevenin's theorem. I hope you all are aware about the statement of Thevenin's theorem, which states that any complicated circuit can be replaced by a simple circuit in which the voltage source is VTH, which is known as the Thevenin's voltage, and resistance RTH, which is internal resistance of the circuit, and a load resistor. Both the Thevenin's resistor and load resistors are in series with the voltage source. So let's see how to solve such problems. If you are having any problem related to the theory or conceptual, do mention in comment section and we'll try to solve that as well. So for the given circuit, let's identify the current using Thevenin's theorem. You all know that in order to use the Thevenin's theorem, you have to identify the value of VTH and RTH. Once you identify, then last step is to draw the Thevenin's circuit. Once you draw the Thevenin's circuit, you can easily identify the current. Okay, now to identify current through 20 ohm resistor, for now RL is equals to 20 ohm, because we are asked to identify current across it. So you can identify any of them at first. Let's identify RTH, or let's determine RTH first. Identify RTH, you have to remove the load resistor. For now load resistor is 20 ohm, so let's remove load resistor, and then next task is to replace the given sources by their internal resistor. If in this case the internal resistor of 2 volt is not given, so we'll assume that this 2 volt is ideal voltage source, so we'll replace it by short circuit. Remember that voltage source is always replaced by short circuit and current source is replaced by open circuit. So let's redraw the circuit. Let the open point this be. I will try to draw it in more easier point. Let's draw this point V on the outermost, and we have drawn the same circuit in more simplified way. Now let's see how the circuit becomes this. For this, now see, if you will remove the RL or this section from the point, BD will open. Okay, here the point BD is open and this will be short circuited. Okay, this will be short circuited means the point A and C will be at the same point. That's why we draw point A and C by this line. Okay, we see that the in between the is B and A. Okay, in between point B and A we are having 6 ohm resistor. Now let's check. In between B and A we are having 6 ohm resistor. Similarly at point B and C we are having 12. B and C 12 ohm resistor. Now D and A, or A and D we are having 3, and C and D we are having 10 ohm resistor. So you can draw any complicated circuit like this, and this is usually we have learned such concepts in order to identify equivalent resistor in series and parallel concept. Okay, once you identify, our task get more easier. Now we can see that RBD, okay, for now which is RBD but it's RTH, we can see that 6 ohm and 12 ohm are in parallel with each other. Similarly 3 ohm and 10 ohm are in parallel, and their resultant will be in series with each other. Okay, so that's a parallel. Okay, if you will identify the value of RTH from this, you will find that 6 and 12 will be 4 plus 30 by 13, which is equals to 6.3 ohm. 3 ohm. Therefore, we can say that RBD is equals to RTH, which is equals to 6.3 ohm resistor. Well, after identifying this, next task is identify BTH. Now let's identify BTH. In order to identify the BTH, remove the load resistor. Okay, now let's remove the load resistor and draw the circuit. That's how our circuit will look like, and our point, this terminal is open. Okay, so it should be open circuit because you have removed this 20 ohm resistor from the given circuit. Now to identify the voltage, you have to identify BTH from this. If you will put the voltmeter, what will be the voltage that will appear in the voltmeter? So in order to identify the BTH, what will you do? You can consider this resistor, or this resistor as per your wish. For now, let's work for identifying the current. Now in order to identifying the first, if you will identify current flowing through them, you can easily if you will identify the current over this, you can easily identify the voltage drop across them. Okay, so current flowing through A, B, C. Okay, current through, now let's see which is the point A, B, C. We are seeing that this 2 volt is in parallel. Okay, this 2 volt is in parallel with the branch ADC and ABC. So current flowing through ABC will be, we know current is equals to V by R. For now, our voltage will be 2 volt. Why? Because this 2 volt is in parallel with the branch ABC. That's why 2 upon total resistor is 6 plus 12. Okay, which is 1 upon 9 ampere. We can easily see that the current flowing through point ABC is 1 by 9. After identifying the current through, now let's identify the voltage, because we have to, in order to find the BTS, we have to identify the voltage across AB. So let's identify the voltage drop across AB. So voltage drop AB will be equals to, what will be the voltage drop? You know the value of current. We know V is equals to I into R. So for now, R is 6 ohm. Okay, this 6 ohm is our R, and our current already is 1 by 9. So total voltage drop is 2 by 3 volt. Okay, once you have identified the voltage this, now your next task is to identify the current flowing through this branch. Okay, current flowing through ADC. Now let's identify current through ADC. Similar concept, this is also in parallel with 2 volt source. That's why the voltage is same in parallel. So it will be 2 volt, and the resistor will be 3 plus 10, because in this branch we are having resultant resistor is 3 plus 10, which are in series. So that's why our total voltage will, total current flowing through ADC will be 2 upon 3 ampere. After identifying the value of current, you can again identify the voltage drop across AD. Now let's identify voltage drop. AD, voltage drop across AD. Similar concept, 3 into this, or R into I. R is 3, 4 now, into I is 2 upon 13, which means 6 upon 13. Usually we write the answers in the fractions, because if you will write the answers in decimals, then it's not possible to write all the decimals, and the chances of not getting accurate answer will reduce. But you can write in the decimals also, but it's better to write in the fractions. Okay, once you identify the voltage drop across AD, now let's identify the voltage drop across BD. In order to identify the voltage drop across BD, let's consider in mesh A, B, D, A. Now let's see the mesh I have mentioned. Okay, if you'll see, we have to identify the voltage across BD. Okay, so identify, you can consider this one or this one. For now we have considered A, B, A, B, D and A, complete closed mesh. Okay, from that you can, now let's put the sign. Okay, now going from A to B. Okay, we have assumed our current flow from this potential to this, so this will be minus, and then B to D, so, and then again current is coming from this direction, that's why we are going to write plus here, minus. Okay, okay, now let's apply the Kirchhoff's voltage law. On applying Kirchhoff's voltage law by using KVL, okay, by KVL. Now let's identify the voltage across the KVL. Our voltage will be A to B. Okay, while going from A to B, we are substituting minus B, A to B, and then again at this terminal we are assuming B is at higher potential, because we are going from B to D, so B to D means minus B, B, D. Okay, then again the current is from upper side to lower, but we have assumed, so that's why plus B, D, A is equals to 0. After considering all of them, now let's the value. Okay, while substituting the value, B, A, B, D is equals to, if we will put BD on other side, we'll get B, D, A minus B, A, B. Okay, we have already gained the value of AD and AB. BAB, BAD is 6 upon 13 minus 2, minus how much? That one is a 2 upon 3. Now take the LCM. 13 upon 3 is 39. Get upon 39 volt. Okay, after obtaining the value of volt, we found that the value of B to D is in negative sense. Okay, we have assumed that our B is at higher potential and D is at lower potential. Initially our assumption was that, but while assuming that, we found that BD is minus 8 upon 31. That means we exact answer is BDB is 8 upon 39 volt. Okay, that's how you can change. Once you identify the value of DB, which is BTH, our last task is to draw the Thevenin's equivalent circuit. Now let's draw the Thevenin's equivalent circuit. Now Thevenin's equivalent circuit will be, this will be our BTH. which will be equals to 8 upon 39 volt. Okay, now replace this by RTH. Our RTH was 6.3 ohm. Okay, 6.3 ohm. And since we were asked to identify the current flowing through load resistor, which was equals to 20 ohm. Now let's identify the current I. I is equals to, all you know, B by R. For now, BTH upon RTH plus RL. For now, our BTH is 8 upon 39 upon RTH is 6.3 plus 20 ohm. After putting the value of RTH, you will gain 7.8 into 10 to the power minus 3 ampere. Okay, minus 3 ampere, which is equals to 0. Or we can write in the milliampere, 7.8 milliampere. Okay, that's how you can identify the current. And as per direction of the current, you found that current moves from D to B. Okay, you also mentioned the direction. So that's how you can identify the current in the given circuit. The circuit may seem complicated, but once you get the concepts, things get more easier. Now let's summarize the question. Okay, so let's go back to the initial point from where we had initiated. And we were asked to identify current through the 20 ohm. In the question, we were asked to identify the current through 20 ohm resistor. So in order to identify the 20 ohm resistor, our first task was to determine RTH. So to determine the RTH, all you have to do is just short circuit the voltage source, or current source will be open circuited, and then remove the load resistor. For now, our 20 ohm was the load resistor. While short circuiting the 2 volt, we found that this A and C will be a same point, will be a single point. That's why we draw the circuit in this way. Okay, after drawing the circuit in this simpler form, this circuit forms in this way. We can easily notice that 6 and 12 are in parallel, and then 3 and 10 are in parallel with each other. After that, these two combination will be in series. So for that, we use this formula, and that's how we gain the value of BD, which was RTH for the case. After identifying the value of RTH, our next immediate task was to identify the voltage, Thevenin's voltage. So in order to identify the voltage, Thevenin's voltage, all you do is just copy the question as previous and remove the load resistor. That's what was done. So we had copied the question as it was and just remove the load resistor, and we consider the point B. Everything was same, just V 2 volt. Okay, and then 6 ohm and 12 ohm, and this was 3 ohm, and that one was of 10 ohm. Okay, since that was more, that your circuit was drawn. After drawing the circuit, you can easily notice that point A, B and C are in parallel. This is in parallel with ADC, and similarly with parallel with AC. So from that, we can easily find that voltage in the parallel are same. Okay, voltage in parallel are same. That's why we identify the current across each branch. After identifying the current, you can easily identify the voltage of 2 ohm voltage drop of each resistor. So we identify the voltage drop of AB. In the similar manner, you identify the value of DA. After identifying the value of AD and DA, we consider this point. At this point was BTH. That's why we consider a closed loop. For now, we consider A, B, D and A. Once you identify, so you can put the sign. And for the sign convention, if you remember the mesh analysis of the previous video, you can easily do that. We know that current is flowing from this A to B. That's why we place the positive sign, then negative sign. As per assumption, we are going from after AB, it's BD. Okay, that's why we assume B is obviously at higher potential, D is at lower potential. Similarly here, the current is flowing from A to D. That's why we placed plus to it, minus to it, and then we apply Kirchhoff's voltage law. Here is Kirchhoff's voltage law. See the sign and place them. After seeing the sign A to B, it's going plus to minus. That's why we wrote minus BAB, and then plus to minus, we wrote minus BD, and after that it's minus to plus. If you'll form the then plus BAD. After assuming all of them, you substitute the value of each. While putting the value of each, we found that BBD comes in negative. That's why you will replace this negative by replacing this. We found that potential of D is higher than the potential of B. That's why in the question, what we do is VTH is equals to not BD, it's DB. D is at higher potential, B is at lower potential. Okay, and later on we draw the circuit. While drawing the Thevenin circuit, we put it like this. This was our Thevenin circuit. Voltage was same, RTH was placed, RL was known. After identifying this, you identify the current. We know current is always equals to V by R. For now, R is in the case of R, it's a resultant of RTH and RL, and both the resistors were in series. That's why we use that formula, and we identify the value of current, which come to be 0. Which can be also written as 7.8 milliampere. And we found that while going from B to D, our answer was negative, and on making that polarity interchange, we found D to B. That's why our conclusion was current flow from D to B. That's how you can solve this problem using Thevenin's theorem. Hope this question is helpful for you and make you more clear. Your concept got a new cue. Like, share and subscribe. Please, have a great time.